Hi, four position problem that I am going to solve is this case. These are the coordinates 0, 0, 100, 200, making an angle 30 degrees, 200, 300, 0 degrees, 300, 200, minus 60 degrees. Okay, let us close this. I have already drawn the positions, four positions required. Here is C1, D1, C2, D2, C3, D3, and C4, D4. And I have also determined the 5 poles. P12 is over here by, by drawing the perpendicular bisectors to the two pairs of points on the moving plane. P12, P34, P24, P23, and P14. I will determine P13 in a minute. If I draw the perpendicular bisector, well, you can already see that C3D3 is parallel to C1D1. So these two curves will be parallel to each other. I'm not going to do that, but I'll leave one of them to tell you that the direction of the pole is important. Okay, I'll neglect it. Okay, this is the direction. P13 will be at infinity, but it has a certain direction. It is this direction, which I will need to later in a minute. Now I have determined P12, P14, P24, P14, P23. In order to draw the circle point, I need the image poles. The image poles, I have to determine P341, P241, and P231. Now let me first determine P341. 3, 4, it is a common point for positions 3 and 4. So I will use the pole triangle P13, P14, and P34. Take the image of P34 with respect to side 1 of this pole triangle, P13, P14, P34. Now, P34 is here, P14 is here, P13 is at infinity. The way I draw that pole triangle is like this. First, I know one side. P34, P14 is side 4. That's fixed. Now, I have to join P34 with P13. P13 is at infinity, so I draw a line from P34 parallel to this line. This last line is going to intersect to be P13 will be on this line at infinity. The same way, P13 will be on this line at infinity. P13, I'll hide this, let me hide this now. These two lines are the two sides of the pole triangle. This is side 3, this is side 4, this is side 1. This side is side 1 of the image pole of the pole triangle. In order to determine P341, I will take the image of P34 with respect to side 1. This is going to be, rename it as P34. This time I will use -1. to indicate that it is P34 in the first position, I'm using P34 subscript 1. Now I can hide these lines, otherwise I will be in trouble. The next thing is P23. In order to determine P23, well, I should not have closed this line. In order to determine P231, I have to use P23, P12, and P13. P12 is over here. From here to here. I don't know why, but I close these. Somehow they turn on again. This is P23. Oh, I need one of these lines. P12, P23. I have to join P23 with P13. So I have to draw a line from P23 parallel to the line that will be on P13 at infinity. That's P13, the infinity direction. And then draw another line from here to P13 at infinity. Hide this. Now, this is side 3. This is side 2. P12, P23 is side 2. P12, P13 is side 1. I have to take the image of P23 with respect to side 1. That will give me P23-1. And lastly, I'll hide this. This is P231, P341. No, it has changed. Rename it. I know I had done it correctly, but okay. And lastly, I have determined P231, P241, P341, and then I have to determine P241. Now, in order to determine P241, I have to use P12, P14, the pole triangle P12, P14, P24. Here is P24, here is P12, and here is P14. Now I have a pole triangle like this. Take, this is side 1, take the image of P24 with respect to side 1. That is going to give you, rename it as P24-1. I will hide these pole triangles. You see, I'm using 3 positions, what I have learned from 3 positions to determine the image poles. Now I have P12, P14, 1, P341, P241, P231, P14, and all the poles. Now consider a pole quadrilateral. If with P12, I will have P341. This is one pole quadrilateral. Let me draw them, and I will show them in color. This is P341. This is one pole quadrilateral. I will first change its color. Okay, that's a pole quadrilateral. Another pole quadrilateral is P34, P12, P34. No, sorry, I cannot use I have to use image poles. P14 and P14 and P231. P14 is here, P231 is here. This is another pole opposite pole, complementary pole. The third complementary pole will be P13, P13, P24. It will be, okay, I'll show it. P241 is here. P13 is at infinity. It will be a line from this point to a point at infinity in that direction. Now, I will not be able to use that. It will be, it's of infinite length. I'm not going to that. So I have these complementary poles. Let me go to the settings. Oh, style. I'll make these dashed. Okay. Okay. These are the two complementary poles. I'm using, let me repeat, the image poles, like that. Now I'm going to draw the complementary pole quadrilateral. These will be the diagonals. 1, 2 to 1, 4 will be side 1. 1, 4 to 3, 4, 1 will be side 2. 3, 4, 1, 2, 3, 1 will be side 2. 2, 3, 1 to 1, P23 to 1, 2 will be side 2. This is your pole quadrilateral. I will use another color for this one. Oh. This is the pole quadrilateral. The two opposite sides, for example, this side 2 is opposite to the side 1, 4, 3, 4, this side. This side. Let me use an arrow to show that. Going from side 1, 2 to 4. Oh, no. I used I have to use this vector. And first I will pull it down and then use this vector. Going from, this is side 1, 1, 2, 1, 4. Going from 2 to 4, this is the vector. Going from 2 to 4 in the opposite side, notice 2 to 4, this is the vector. One is going down, the other is going up, from 2 to 4. Notice, for example, going from 3 to, this is side 4, going from 3 to 1, or 1 to 3, let me do it like that, 1 to 3, you move like this. Going from 1 to 3, you move like this. This is important. These I will cancel. But keep that in mind, please. Now I will select two opposite sides of the pole quadrilateral. Let me select side, well, these are two parallel. Okay, I'll do that. I'm not sure because I usually do it differently each time. This is side 1, going from 2 to 4. This is side 4. This is side 1. This is side 4. 3, 4, 2, 3. Honestly, 3, 4, 1, 2, 3, 1. This is side 3. This is side 1. 3 and 1. Side 3 and side 1. I will determine the perpendicular bisectors to these sides. This is the perpendicular bisector to P1 to P14. This is the perpendicular bisector to P341, P231, side 3. I will, now what I will do is, I will select a slider. It is going to be, I will call it alpha. I hope I haven't used it. So that it is an angle, alpha. It's going to change 360 degrees. No, it need not change for 360 degrees. I'll make it 180 degrees, but I will change it by 0.5 degrees. Okay? What I will do is, I will measure alpha in counterclockwise direction. I will draw a line that makes an angle in counterclockwise direction with respect to side 1, going from 4 to 2. I'll take point 2 as the center, 4 to 2, okay? This is the line. So, in counterclockwise direction, I will take angle, here, angle alpha, in counterclockwise direction. This is the point. I will draw a line and then I will determine the intersection of that line with this perpendicular bisector. I will hide this object. I will hide this object. I will draw a circle, and then, well, I'll hide this perpendicular bisector as well. I have used it. I will draw a circle with center this point, passing through these two poles. Okay? I don't like to use A, but okay, I'll leave it like that. Next, this is from 4 to angle alpha counterclockwise. I'm enlarging it so that we can see it easily. This is the line 4-2. I have to measure angle alpha with respect to this line in counterclockwise direction. It will be like this. So what I will do is angle with a given size from here 4 to making an angle alpha in counterclockwise direction. Now it is this line. Hide this. The intersection is going to be over here. Now I will draw a circle. No, not. We center this point, passing through these two poles. Okay. Now, these 2 points intersect, these 2 circles, intersect over here and over here. I will call this point K. K is from the word Kreis, K-R-E-I-S in German, meaning circle. K, okay. This point, I'll call it, no, cancel. K prime. These points will be on the circle point curve. Now, let me move it over here. Take my word, using the, if you had to do this with ruler and a pencil and protractor, it is really hell of a time. What I will do is show trace. No. Show trace. And let me Now this is the curve. As you go on, you obtain more points. Let me stop this. Now what I will do is, I don't need these circles. I don't have to see these circles. But remember that those points are at the intersection of two circles. It has changed its name. I called it K, it's the D. Okay. I will, let me do that, locus of this point, this portion. Locus, I have to find the other point. Yes, this point. Yes. This is the circle point curve for this, these four positions of the moving plane. I can select any point A, B on this circle point curve, determine its corresponding center point to design a four-bar mechanism. I'll do that in a minute, but first let me show this. The 4 points to lie in a circle must be on this curve. A1 must be on this curve. Okay. First of all, I will stop this. It really slows down. Okay. What I will do is, I will select a point, 2 points, A, B on this curve. I'm not sure whether I can do it or not, but let me point on an object. I will select a point over here, call this point A-1, because that's the first point position. Take another point. Let me take it over here. I don't really know what I'm going to end up with, because I usually do it differently each time I solve these problems. B-1. Here is B1, here is A1. Now, once I select A1, B1, I can treat this problem as if it is a 3-position synthesis. Or if you want, I can treat it as if it is I can, in order to determine A0, I can treat it as if it's a 3-position synthesis. Because I know that it will pass through the 4th position if I select A on this line, on these curves. Now, if this is A1, let me determine draw the pole triangle for positions. Okay, I'll again use 1, 2, 3. Positions 1, 2, 3. I know it's 1, 3 is at infinity, but I will use that. I will select, this is point position, pole 1, 2. This is pole 2, 3. Where is it? 2, 3 is over here. 1, 2 is over here. 1, 3 is at infinity in that direction. Let me again show the perpendicular, the direction C1, C2. Okay. This is the direction. So the pole triangle will be like this. 1, 2. From here, I have done this before. Remember, this is line. And then 2, 3. Hide this. The pole triangle is P12, P23, P13 at infinity, P13 at infinity. These two lines, okay, parallel lines. Where's that parallel line? It's not the, let me see. These are not parallel, is it? Yes, it is almost parallel. Notice this curve, I have to show that. As I said initially, the circle point curve passes through the poles P1241, P341, P231, P12, P14. That makes 5. It is going to pass through P13 as it goes to infinity. Okay? It's going to pass through P13 as it goes to infinity. Now, I have selected, this is my pole triangle. That is point B, A1 that I have selected. This is side 2 of the pole triangle. This is side, okay, I'll color this so that, okay, this time I'll use green. That's not parallel. I don't want to draw another. I think this is, it doesn't look parallel, but I'm not sure. I haven't drawn any other line. Such, this is the parallel. This must be parallel, okay. Okay. I hope I'm doing right. Well, let me check it. Yes. It is parallel. Okay. Now, this is my point A1. I will first determine the ground point. How do we determine the ground point? We take the image of A1 with respect to side 1. This is P12, P13 at infinity. This is side 1. So I will take the image of A1 with respect to side 1, this is going to be, rename it as A123. Now if I take the image of A123 with respect to side 2, this is 1, 2, 2, 3, side 2. This is A-2. If I take the image of A123 with respect to side 3, where is side 3? This is side 3. So I will take the image of A123 with respect to side 3. This is, rename it as A-3. How can I determine A4? Now, I have to use another pole triangle. For example, I can use a P12, P14, where is P14? Is here. P12, P14, and P24. P24 is here. I can use that pole triangle. Let me do that. Well, I'll hide these because this pole triangle I will hide to show the fourth point. Now I will use the pole triangle, which I have done before. I cannot, you can open the previous one, but I don't think you'll be able to find it. P12, P14, P24, P14, P12, P24. Now I will take the image of A1. Here is A1. With respect to side 1, this is side 2. 1, 2, 1, 4. This is side 1. This is side 1. 1, 2, 1, 4. So I will take the image of A1 with respect to side 1. This point is not A123, it is A124. Okay? A124. Now if I take the image of A124 with respect to side 4, which is side 4, this is side 4. Okay? This is side 4. If I take the image of A124, this point, with respect to this side, 4, I determine A-4. No, it shouldn't be that point. I think I have done wrong. That's not the point. Let me decrease the size to see. Oh. No, this is the point. I'm sorry, this is not the point. Ah. Where is it gone? All my points are gone. Ah, okay. I think I got it. Now, delete this point. Ah. I don't know why that point, I have that point, but this is A-4, okay. Okay, I'll hide it. I don't know, well, I think these points are in my construction of the circle point curve, okay? Now I claim A1, A2, A3, A4, A1, A2, A3, A4 lie on a circle. Let us see that. I'll take 3-point circle. I'll let it pass A1, A2, A3, and A4. Can you see it? Those 4 points lie on a circle. Okay? Now what I will do is move A1. If that is A1, the center of the circle, sorry, where is it? Oh, here. This point is going to be A-0. Now I can attach, where's my point here? I can select all kinds of points. Okay. Now I will call this point A0. Now I have one crank. I don't like its color, that color. Let me make it okay, brown. Next, I had selected this point. I will repeat the same process again. Okay? I will repeat the same process again to determine B0, B1. Thus, I will obtain a 4-bar mechanism in the first position. This CD is connected to A0A. A is on the A1, C1, D1 are on the same rigid body. Now I have to, and B1 is on the same rigid body. Now I will I don't want to continue because it's going to be, I will be repeating what I have said for 3 positions. Let me show you. Now, if I were to say, if I prefer to select A0, B0 first, what I would do is I would first select, I will use the poles themselves, not the images within first position, but the poles themselves. I will obtain a similar curve, which I will call, this is the circle point curve. I will obtain a center point curve on which I will select A0 and B0 and determine A1. Usually you would not use both circle point and center point together. The reason is you cannot arbitrarily select a point. Once you select a point A on the circle point curve, you cannot arbitrarily select a point A0 on the center point curve. Once you have selected A on the circle point curve, A0 is fixed. Once you select A0 on the center point curve, A1 is fixed on the circle point. So because of this, you have, depending on the problem, you either use a circle point or a center point. You don't use both. That's the final, the idea. This curve, you can pick up any point on over here and over on this locus and this locus. The cubic can be one continuous curve, or it can degenerate into two. In certain cases, it will degenerate into a straight line and a circle, depending on the problem. In some cases, it will degenerate into a straight line and a hyperbola. These are the special cases. I'm not going to discuss those. But in general, you can design for 4 positions, as I have shown over here. You will select another point B1 and determine B0. That will give you a 4-bar mechanism with which you can move the stitched body in between 4 positions. Of course, you have to check. You must check for the motion. The reason, number 1, the mechanism may lock. It may not pass through all those 4 positions in the same configuration. It has to change its configuration. You cannot change the configuration while the mechanism is moving. So that's out. Number 2, in some cases, for example, in this case, if you move from position 1 to position 2, then to position 3, back to position 4. That's something that you don't want. So, yeah, actually the mathematics does not know the order. What I call 1, you can call 2. What you call 2, I can call 3. Okay, the order is not important in this case. In this drawing, the order is what we are thinking. It is not the geometry consideration. It is your thought, the order you give. But during the construction, you are not using the order of the positions. So the mechanism may move from first position to fourth, third, and second. So you don't know that. Intuitively you want it, but the mathematics is not concerned. So you have to check for that. In some cases, you have to check the transmission angle as well, because if the transmission angle is too bad, you will not be able to use it. As you can see, as we increase the number of positions, our choice starts getting limited. For example, you cannot select A anywhere else on than these curves. Sometimes, if you cannot find a satisfactory solution, you may want to change the position of the intermediate links slightly. When you change it slightly, its variation may be quite big on the motion on the circle point curve. I mean, the circle point curve can change drastically. So what you do is, for example, you usually keep first and fourth positions fixed. You slightly change the second and third positions. You may slightly change second and third positions to come up with a good solution. That's usually what you do if you cannot find a good satisfactory result from these given 4 positions. Okay. There are lots of things that you can say. Okay. For example, when I see A1 to A4, first of all, I have to see A1, A2, A3, A4 in sequence. This is quite important for me if I have to use this as a crank. If I have to use this as a rocker, I don't need that. But in that case, I would consider the angle it moves from the first to the fourth position. If it's that large, it cannot be a rocker. Okay, you may have problems with that. So you have to check. Okay, this is all that I'm going to talk about it right now. I will post different examples as well and show another example in class on using a different problem.